Okay, so this is just a slight update to the previous video. A friend of mine pointed out that I was using the Find Orb software somewhat incorrectly. By that I mean that the residuals that are indicated here, you'll notice they are indeed relatively high across the board for these observers, and that's somewhat unusual. So turns out there's this function here that if you click this a few times, then you'll start to see perhaps an improvement in the orbit solution. So that's what I should have done in the previous video, and that would have shown a more correct analysis of the measurements that were taken. So anyhow, I will go ahead and show the same results in this video, or similar results. And so let's go ahead and do that. So again, what I want to do is I have loaded up the images for a given data set, and the idea here is just to show what we can, one of the techniques we can use to take measurements of an object that it's contained within this data set. So first off, let's go ahead and say, this is C95 as the observatory from which these images were taken. So I'm going to go ahead and let's pretend that only observations up to this point have been made available. So let's say we have these available, and so we'll go ahead and do similar to the last video in the sense that we'll get an initial orbit of the object, and we'll compute the ephemerides for the each image, and so then that'll allow us to generate stacks for the object in question. Again, this object, for some odd reason, the orbit takes a lot longer to compute than most other objects. But anyway, so I'm going to click this button, return ephemeris, and that will in turn attach the motion of the object for each image. And so what we can go ahead and do now is view the images. And before I do that, though, it's also nice, there's another column actually that I've added that allows you to determine pretty easily whether or not the object is actually in the field of view of that image. So as you can see, yeah, it's not in the field of view here for these images, so I'm going to go ahead and remove those images from the data set. Okay, now let's go ahead and try it again. So again, quite similar to last video, but this time I'm just going to show what the correct residuals should be, having taken into account the improved orbit solution. Alright, so I'm going to select the first 1/3 of the images, create an observation. Again, need to load the star catalog first. And so we got one observation, and we'll do a second, and finally the last one here. So okay, so that's 3 observations of this object, again 2005 QQ87, and so we'd like to determine again whether or not these observations have good measurements. So yeah, let's go ahead and remove the originally submitted. Well, actually, let's go ahead and see what the measurements were originally. So this is how it was originally, and so view and find orb. Again, this object takes a while to get its orbit computed. So we'll just give it a moment here. Okay, so C95, and again, as you recall last time, yeah, 2.1 is pretty high, but again, the reason for that is I guess these observations were excluded. So let's go ahead and do this filter obs button here a few times, and so you'll note one pass, it already went down some. The orbit, I suppose, has been improved, so these are better residuals, and so we'll go ahead and do this why not a couple more times. Let's see here. Okay, no changes made. So I guess that's as good as it can get. So again, the originally submitted observations, it looks like we have a 1.1, a 1.4 perhaps, and then again Z80, 1.3. But anyway, what's important is, again, these are the original 3 observations, so 1.1, 1.4, so I'm going to go ahead and close out of that and replace with these new measurements, these new observations, and we'll see what improvement, if any, has been made there. Okay, so as before, I'll click filter obs a few times here, and I'll just keep going until it says no more changes made. No changes made. Okay, so looks to me like, yeah, again, before we had 1.1 and 1.4, and now the maximum here is 0.58. So I would say, yeah, 0.58 is certainly better than 1.1 or 1.4 for that matter. So definitely an improvement, and so that's reassuring, at least on this particular object, we were able to get improved measurements of the object. So anyway, again, this is just another way of using Tycho to generate observations of objects. So didn't have to run the tracker on this. However, I will say the tracker usually does provide very good measurements, and I'm working on an analysis of that, which I hope to present soon. So anyway, stay tuned. I have a lot more things coming up. So thanks for watching, and see you next time.